Are you caring for a loved one with dementia? You don't have to figure this out all on your own. Welcome to Truth, Lies, and Alzheimer's, the show that helps you reimagine a new relationship with your loved one, a relationship a little more free of stress and anxiety. Join host Lisa Skinner and her 30-plus years of experience as she guides you on a new path to a better relationship with those you care for. Here's Lisa.
Hi, everybody. I hope you're as excited as I am for this new episode of Truth, Lies, and Alzheimer's with me, Lisa Skinner, your host. And today I'm going to be talking about a topic that I have been keeping you updated on pretty regularly. And I came across this article in the medical news today. And I was blown away when I read it because it is the most detailed, comprehensive article on the new drugs that have been approved by the FDA, aducanumab and canumab. So this is, to me, a really noteworthy article, and the information is so important because it really strips everything down to how effective they're finding this drug to be for the treatment of Alzheimer's disease. And the question is, how are the newly approved Alzheimer's drugs stacking up against expectations? Because the expectations in the beginning, if you remember, were extremely high. So we're going to address all those questions and more in this episode. So the title of this article is Alzheimer's, Are Newly Approved Drugs Making a Real Life Difference? And I'm really excited about this. And I think you'll find the information, like I have, absolutely fascinating and the truth. This article was written by Deep Shukla on August 25th of 2024, and it was fact-checked by Jill Seladi-Schulman, a Ph.D. So it's been fact-checked. After a lull of nearly 2 decades, the Food and Drug Administration has approved some novel drugs for the treatment of Alzheimer's disease since 2021. Most of these drugs are antibody therapies targeting toxic protein aggregates in the brain. Their approval has sparked enthusiasm and controversy in equal measure. The core question remains, are these drugs making a real difference? That's what they investigated and wrote the article about. As we all know, Alzheimer's disease is a neurodegenerative disease that involves a gradual and irreversible decline in memory, thinking, and eventually the ability to perform all daily activities. Aging, as we know, is the leading risk factor for Alzheimer's disease. And a rapidly aging population has made it a public health crisis. In 2019, 57 million individuals around the globe had Alzheimer's disease. And this number is expected to reach 153 million by the year 2050. Let's do the math. That's only 25 years away. It's going to sneak up on us way faster than we're prepared for. This underscores the need for disease-modifying treatments that produce a lasting change in the trajectory of this disease, slowing its progression. However, until recently, efforts to develop disease-modifying therapies for Alzheimer's disease have not been successful. Most of the clinical research to develop disease-modifying therapies for Alzheimer's has focused on targeting the beta amyloid protein, whose abnormal accumulation is generally considered to lead to the development of this neurodegenerative disorder. So, are these new drugs that have been developed a breakthrough or a slow start? Aducanumab, an antibody targeting amyloid beta protein deposits, received Food and Drug FDA approval for the treatment of Alzheimer's disease in 2021 and was considered the first disease-modifying therapy for this condition. However, the clinical trials involving aducanumab failed to produce consistent improvements in cognitive function, which led Biogen, the company that produces it, to announce that it will eventually suspend its sales. Since then, two other anti-amyloid antibodies, Biogen's lecanemab and Eli Lilly's donanemab, have demonstrated an ability to slow cognitive decline in individuals with early Alzheimer's disease in phase 3 clinical trials and have received FDA approval. After decades of clinical research failing to produce effective disease-modifying therapies, the approval of lecanemab and donanemab has been viewed as a breakthrough and met with enthusiasm by clinicians and researchers. But, there's a but, some researchers have raised concerns about the modest clinical benefits conferred by these anti-amyloid therapies, citing safety risks and a lack of cost effectiveness. Dag Arsland, MD, he's a professor of the old age psychiatry at King's College, London, in the United Kingdom, told Medical News Today that while there are indeed challenges at both the clinical, societal, and healthcare levels, we should not forget the opportunities and the breakthrough that after decades of very costly negative trials, we finally have unequivocal evidence that it is possible to reduce the disease progression. Similarly, Paresh Malhotra, Ph.D., professor of clinical neurology at Imperial College London in the UK, noticed that despite the modest efficacy of these anti-amyloid therapies, he quotes, "It is important to recognize that these drugs are the first to have clinical effects which appear to relate to a key mechanism of disease progression, and their introduction may accelerate treatment development and transform clinical services for Alzheimer's disease, which is the most common cause of dementia worldwide," end quote. The development of anti-amyloid antibody treatments, such as donanemab and lecanemab, is based on what is called the amyloid cascade hypothesis. What does that mean? Well, according to this hypothesis, the accumulation of the beta amyloid protein triggers other changes in the brain, leading to the development of Alzheimer's disease. I haven't heard that before. Specifically, the formation of beta amyloid aggregates is considered to lead to inflammation, oxidative stress, damage to neurons, loss of synapses, which are the links between neurons that allow them to communicate, and ultimately to cognitive decline. Consistent with this, the accumulation of the beta amyloid protein precedes the decline in cognitive function including memory and decision making, by several years. The beta amyloid protein is formed after the cleavage of a larger amyloid precursor program by secretase enzymes. Each unit of the beta amyloid protein is referred to as a monomer, and these monomers can aggregate to form short chains called oligomers, which consist of 2 to over 50 monomers and are soluble. Beta amyloid monomers can also aggregate to form larger soluble protofibrils and insoluble fibrils. The insoluble fibrils then assemble to form plaques in the extracellular space between neurons. If you're totally confused, I get it, because yeah, that's pretty technical. But previously, the amyloid plaques were thought to be toxic and responsible for the development of Alzheimer's disease. However, and this is new information, in the past 2 decades, studies have suggested that beta amyloid oligomers are more toxic than amyloid plaques, and oligomers could play a larger role in the development of Alzheimer's disease than once believed. The accumulation of beta amyloid aggregates is thought to occur due to the impaired production or clearance of beta amyloid protein. And these drugs, this is a side note, these drugs were showing promise of clearing those proteins, beta amyloid proteins. In the past 2 decades, several drugs have been developed that either target the enzymes involved in the production of beta amyloid or facilitate the clearance of beta amyloid aggregates. In other words, the proteins that form in the brain. However, these drugs have been unsuccessful in receiving FDA approval due to their severe adverse effects or failure to produce the desired clinical effects. The anti-amyloid antibody donanemab, aducanumab, and lecanemab are the only therapies that are targeting beta amyloid aggregates to gain FDA approval. These antibodies differ in their affinity for the various types of aggregates of the beta amyloid protein. So what donanemab does is binds to a specific form of beta amyloid protein that is only found in plaques, whereas aducanumab and lecanemab bind to beta amyloid oligomers, protofibrils, and plaques. Lecanemab shows the highest affinity for beta amyloid protofibrils, whereas aducanumab has a higher affinity for insoluble fibrils. What that means, I really don't know. One of the supposed mechanisms through which anti-amyloid antibodies produce their therapeutic effects is by activating an immune response against the beta amyloid aggregates, resulting in their removal. Anti-amyloid antibodies can also potentially destabilize these plaques or bind to oligomers to neutralize them. Now, the FDA granted accelerated approval to aducanumab for the treatment of Alzheimer's disease in 2021 based on its ability to clear amyloid plaques. Now, while aducanumab was successful in clearing the plaques in the brain, its effect on cognitive function were inconsistent across clinical trials. The approval of aducanumab, despite the lack of evidence to support its therapeutic effects, led to controversy about the FDA's approval process and a reluctance to prescribe the drug. And as previously mentioned, and this is as of 2024, Biogen, the manufacturer of aducanumab, has suspended its sales and development. In contrast, both donanemab and lecanemab have shown ability to clear amyloid plaques while slowing down disease progression. These therapeutics are more effective in individuals with early stage Alzheimer's disease and lower baseline beta amyloid levels. So the FDA went ahead and granted lecanemab and donanemab approval for the administration via intravenous infusion in individuals with early Alzheimer's disease, which includes those with mild cognitive impairment or mild Alzheimer's disease. Lecanemab is indicated for administration every 2 weeks, where donanemab needs to be administered every 4 weeks. One of the unique features of donanemab is that participants can discontinue treatment after achieving complete plaque clearance. The buildup of amyloid plaques takes several years, and it is assumed that individuals will potentially require minimal further treatment. So here's some statistics for you on its effectiveness. Participants in the phase 3 trials for lecanemab and donanemab showed a 27% for lecanemab and for donanemab a 36% slower decline in cognitive function compared with placebo. However, some researchers have argued that these outcomes are modest and comparable to the effects of symptomatic treatments such as acetylcholinesterase inhibitors, and that the symptoms without changing the trajectory of the disease. The changes in cognition noted above were measured using the clinical dementia rate sum of boxes. Researchers have also noted that the impact of these anti-amyloid therapies was not clinically meaningful when evaluated based on the absolute difference in decline in cognitive function, measured directly in terms of difference in scores on that clinical dementia rating sum of boxes scale between the placebo and anti-amyloid antibody treatment groups. More objective measures of cognition, such as the mini mental state examination, reported only a 14.8% slower decline in cognitive function in individuals treated with donanemab. So, in other words, it has been argued that currently available evidence suggests that these anti-amyloid drugs may only provide a modest clinical benefit. Albert Espay, MD, a professor of neurology at the University of Cincinnati, told Medical News Today that the efficacy of these drugs is not translated into improvements, but they just mean a statistically significant but clinically meaningless slower decline. I think that's pretty strong. Dr. Espay further noted that the safety concerns, along with modest clinical benefits, makes the case that the costs are not commensurate with the efficacy. However, what constitutes a clinically meaningful effect remains a contentious issue. Some researchers have posited that the clinical benefits of anti-amyloid antibodies indicate the validity of the amyloid cascade hypothesis. However, others have argued that this conclusion is still premature, with many questions yet to be answered. According to the amyloid beta hypothesis, the ability of aducanumab to clear plaques should have resulted in slower progression of Alzheimer's disease, but it hasn't. However, critics argue that trials involving aducanumab showed effective removal of amyloid plaques without consistently producing clinical benefits. So what that's saying is, even though the drug is effectively clearing out the plaques that are forming in the brain and suffocating the brain cells and the neurons, the cognitive decline is insignificant. Donanemab removed about 85%. This is really interesting. It removed about 85% of plaques in patients in the phase 3 trial, but only resulted in a 14.8% slower decline in cognitive function, as mentioned using the mini mental exam scores. So, what does this boil down to? The FDA's decision to grant approval to aducanumab was grounded in the amyloid cascade hypothesis. In other words, its ability to clear out the plaques. Alzheimer's disease also involves the accumulation of the tau protein inside the neurons and the extent of tau accumulation rather than beta amyloid, which is associated with the magnitude of cognitive decline. Now, Dr. Perlmutter, who's a neurologist and fellow of the American College of Nutrition, commented that, quote, pharmaceutical interventions based on reducing beta amyloid or reducing its production are leveraging the idea that beta amyloid is playing a central role in the production and progression of Alzheimer's disease. This hypothesis, however, has been widely challenged, and results of clinical trials of these medications reveal minimal efficacy and significant associated risk, end quote. As a result, some researchers argue that instead of indicating that the beta amyloid pathway plays a focal the development of Alzheimer's disease, the modest efficacy of the anti-amyloid antibodies suggests that the beta amyloid pathways contribute to the development of Alzheimer's disease along with other pathways. So that they now believe, contrary to popular belief or previous belief, that there's a lot more to it than they originally believed in terms of what actually is causing Alzheimer's disease. It's more involved than just these plaques and tangles, and that it involves other pathways. So basically, what they mean by this is a complex network of factors, including those associated with environment, oxidative stress, inflammation, metabolic factors, and genes unrelated to amyloid pathways, also play a role in the development of Alzheimer's disease. Also, according to this view, anti-amyloid therapies could have a role in the treatment of Alzheimer's disease, but in combination with other therapies. Alternatively, the aggregation of beta amyloid could be a downstream phenomenon or symptom of other impaired biological pathways. Dr. Perlmutter explained, and this is a quote, "It is now clear that metabolic dysfunction upstream of amyloid plaque formation is central to the activation of the brain's microglial cells, and this phenotypic change both enhances beta amyloid formation while reducing its degradation. In addition, microglial activation threatens the viability of neurons and leads to synaptic degradation, both central features of Alzheimer's disease. As such, therapies targeting brain metabolism will likely provide substantial benefit for Alzheimer's disease, as has now been demonstrated in preliminary studies using GLP-1 agonists," added Dr. Perlmutter. So they now kind of go into a little bit of a deep dive about safety risks and accessibility of these new Alzheimer's drugs. The modest clinical benefits conferred by anti-amyloid antibody treatments needed to be weighed against the risks, costs, and accessibility of these therapies. Adverse effects have been observed in a significant proportion of participants in the phase 3 clinical trials for lecanemab, about 45%, and donanemab at a high 89%. For instance, patients undergoing anti-amyloid antibody treatments often show changes in the brain known as amyloid-related imaging abnormalities, or ARIA, A-R-I-A. These changes are observed during routine follow-up MRI scans and involve either brain swelling, also known as edema, or small areas of bleeding due to the rupture of blood vessels, also known as microhemorrhaging. For instance, 21% the individuals treated with lecanemab and 36.8% of individuals treated with donanemab showed ARIA during the phase 3 trials. Most cases of ARIA were asymptomatic and resolved within 10 weeks. While the symptomatic cases of ARIA are typically mild to moderate in severity, severe adverse effects such as seizures and death have also been reported. For instance, only around 1.6% of participants in the phase 3 donanemab clinical trial experienced severe adverse effects related to ARIA, whereas the death rate in the donanemab group was 0.35%. Besides concerns over these serious adverse effects, the long-term effects of amyloid-related imaging abnormalities, even when mild to moderate in severity, are not known. The infusion of these anti-amyloid antibodies is also associated with adverse effects, such as nausea, fever, rash, and dizziness. Now, such infusion-related reactions were observed in 24.7% of patients treated with lecanemab and 8.7% of the patients treated with donanemab. These amyloid-related imaging abnormalities and other adverse effects necessitate frequent MRI scans and clinical follow-ups. Also, individuals carrying at least one copy of the APOE4 gene, which is a gene linked to increased Alzheimer's disease risk, they found were at higher risk of brain swelling in the phase 3 trials for donanemab and lecanemab. Moreover, these drugs had lower efficacy in individuals with one or more copies of APOE4. Don't forget, you can inherit an APOE4 gene from one parent or both parents. So you can end up having one APOE4 gene or two. And if you have if you've inherited that gene from both parents, that increases your risk of developing Alzheimer's disease. Still doesn't mean you definitely will, but increases it. So, because of this finding, individuals need to be genetically screened before the onset of anti-amyloid treatment. Anti-amyloid immunotherapies are also associated with a reduction in the whole brain volume, accompanied by an increase in the volume of ventricles, which are the fluid-filled spaces in the brain. An increase in the volume of ventricles and a decrease in whole brain volume are associated with reduced cognition. But Whether a causal relationship exists between these changes in brain volume and cognitive function is still unclear. So there is a need to examine the impact of these changes in brain volume after anti-amyloid treatments. Interestingly, donanemab treatment resulted in a smaller reduction in the volume of the hippocampus, which is the brain region that plays a critical role in learning and memory. Only a few individuals with Alzheimer's disease in the population are likely to meet the criteria for inclusion in the clinical trials for lecanemab or donanemab. The patients included in these studies were younger and had fewer occurring medical conditions. The treatment of a real-world population consisting of individuals with Alzheimer's disease and co-occurring conditions is thus likely to lead to more adverse events or reduced efficacy. Besides the management of adverse effects, the screening and diagnosis of individuals eligible for anti-amyloid therapies poses another challenge for the healthcare system. Most individuals with Alzheimer's disease are not diagnosed until later stages of the disease, which we know, and early diagnosis would require screening a large number of individuals using imaging scans or by measuring cerebrospinal fluid biomarkers, which is not state of the art yet. So, bottom line, the broad availability of these drugs would entail a substantial investment of resources for the screening and diagnosis of individuals with early Alzheimer's, genetic testing for the APOE4 gene, and the monitoring and managing of the ARIAs and infusion-related reactions, regardless of their severity. Jennifer Keane, who is the head of policy at the Alzheimer's Society in the UK, told them that, quote, confirming eligibility for new treatment requires specific diagnostic tests. And currently, a third of people living with dementia in the UK don't get a diagnosis at all. We need to see investment in diagnostic infrastructure and workforce to ensure that people who are eligible for treatments can access them when they are most effective, which appears to be in the early stages of Alzheimer's disease. And we're not there yet. We're not even close to being there yet. And don't forget, because I've mentioned this before, the number one leading cause of death in the UK is Alzheimer's disease. They really have a serious, serious epidemic of Alzheimer's disease in that country. And then in addition to what I just said, the annual cost of receiving infusions of lecanemab and donanemab was around $26,000 and $32,000 a year, respectively. However, this does not include the cost of screening and diagnosis, genetic testing, and monitoring and managing the adverse effects. So, advances in diagnostic methods and the identification of novel biomarkers for monitoring treatment outcomes have the potential to reduce costs and improve the accessibility of these anti-amyloid therapies. I know that a lot of what's contained in this article is a little difficult to follow, but I think we can all deduce from the content of the information that was provided in this article is turning out to be less promising than promising at this particular stage, which is disappointing. But it doesn't mean that out of their research and results of what they explained in this information won't lead to better outcomes as the drug is continued to be used for treatment therapies. So please take from this what you can, but it certainly sounds like all of the negative aspects of these drugs do outweigh the results, the efficacy that these drugs are showing. That's what I got out of it. So I don't know if you understood it the same way I did, but it is very detailed information. It's the most detailed information about these drugs that I've been able to find so far. And it really spells everything out for us, which to me, I'm not taking away a real good positive impression about the treatment with these drugs. Hopefully that will change as research continues. So that'll do it for today's episode of the Truth, Lies, and Alzheimer's Show. I'm Lisa Skinner, your host. I hope you found this information valuable, and if your loved one or somebody you know is considering undergoing these treatment therapies, you might want to question the doctors involved about some of the things that I presented to you today. So I look forward to you coming back next week for another new episode of the Truth, Lies, and Alzheimer's Show. Again, I'm Lisa Skinner, your host. I appreciate you taking the time to listen today, and I'll look forward to having you back next week. Bye-bye for now.
Thank you for listening to Truth, Lies, and Alzheimer's. We hope you found something in today's episode that helps. We understand that caring for a loved one with dementia can be the challenge of a lifetime, but you don't have to do it alone. If you're ready for exclusive access to even more great content and resources, head on over to Facebook and join Lisa's Minding Dementia Support Group. We're a community of like-minded caregivers, and we're here to help.